Okay, in this problem, the degree of the polynomial is 3. So we will have or can have up to 3 roots. Now, maybe some of them repeat. So we want to take a look at what are some possible rational roots. So what we're going to do is we're going to take the constant, and I want all of the factors that we can get, rational factors of 4. So we can get positive and negative 1, positive and negative 2, positive and negative 4, the factors of the constant. Then I want to look at the factors of the coefficient of the leading term, the degree 3. And we have positive and negative 1, positive and negative 3. Now, what we're going to do is we're going to take a look at all possible roots that we could get. And that is by picking a number in the numerator with a number in the denominator. 1 over 1. So we have 1 as a possible root. 2 over 1. Positive and negative, 2 over 1. Positive and negative, 4 over 1. Then positive and negative 1/3, positive and negative 2/3, positive and negative 4/3. That's where we're going to get all the possible solutions we could have. So let me put those down. We could have positive and negative 1, positive and negative 2, positive and negative 4, positive and negative 1/3, positive and negative 2/3, positive and negative 4/3. So we try with, and I believe synthetic division is going to be the way that you want to go, because it's going to be a lot quicker for you to try to find the root or solution. So we try a bunch of these. So I'm going to try, for example, 1. So if I try 1 as a root, I'm taking the coefficients of each of the terms in the polynomial of 3, negative 2, negative 6, and 4. Now, I also check here the variations in the changes in the signs of the polynomial. This went from positive to negative. That's one change. Negative to negative did not change. Negative to positive changed. So when it changed twice, that meant that we can get we can get 2 positive roots. Also, if we subtract an even number, we could get 2 minus 2, or we could get 0 positive roots. So we could get 0, we could get 2 positive roots. To find out how many or what negative roots we get, we put in f of negative x. Now, negative x cubed is negative x cubed, so we're getting a negative 3x cubed. A negative x squared is still going to be positive x squared, so that's going to be a negative 2x squared. And a negative x times negative 6 is positive 6 plus 4. So what are the changes or the variations in signs here? This went negative to negative, then we went negative to positive, then we went positive to positive. So we can get 1 negative root. So we could get 2 positive roots and 1 negative root. So let's take the synthetic division. Remember from last week, bring down the 3. 1 times 3 is 3. Adding, negative 2 and 3 is 1. 1 times 1 is 1. 1 and negative 6 is negative 5. Negative 5 times 1 is negative 5. And we get negative 1. So that means that we did not get a remainder of 0. This is not a root. Now, I have a bunch of different ones to check. And what I'm trying, yeah.
Sorry, so when you don't get a remainder of 0, that's when you have, it's not a root?
That's correct.
Okay.
So we can try other ones. We can try 2, we can try 4, but I'm going to jump right to one that does work so that we have a bunch of problems to check. So I'm going to pick 2/3. Still using 3, -2, -6, and 4. So bringing down the 3. 2/3 times 3 is 2. -2 and +2 is 0. 2/3 times 0 is 0. -6 and 0 is -6. And 2/3 of -6 is -4. And I did get a remainder of 0. Therefore, I know that 2/3 is one of the roots that works. Now, I can take what I have in this bottom row here, and I can make a reduced form because I know that x minus 2/3 would divide in and give me 3x squared minus 6. This is your x squared term, this is your x term, this is the constant, and this is the remainder. So now what I can do is set this equal to 0, and I have 3x squared equals 6, x squared equals 2, so I'm getting x is equal to positive and negative square root of 2 for the other two solutions. And you can see that I got 2 positive, 2/3 and positive square root of 2, and I got 1 negative, the square root of 2. Now again, I just went to 2/3. You might have to try several different possibilities because there are a bunch of them here to try. And I just wanted to skip right down to one. I did one that didn't work, and I now wanted to do one that did work so I could continue down in the problem. It is much easier to do this with synthetic division than it is to do it by long division.